we are going to be running an API titration analysis of this invert emulsion. In this titration analysis, we are going to be determining the alkalinity of the whole match, and then the chlorides, and then the calcium content. So we are going to be using some utensils here, starting with a sample of mud. Also, we have here PNP, which is normal proxypropanol. As a matter of fact, we are going to do the analysis in this jar, and I'm going to start by putting approximately 100 cc's, which I already measured, of the PNP. And now my next step is to take a sample. So I'm going to be using a 5 cc syringe, and I need 2 cc's. That's required by the API, a standard procedure. Of course, we could go to a larger sample if we need more precision. But in this particular case, I will go all the way, for example, to, let's say, 3 or 4, in this case, 3. Wipe this a bit so I can see the reading. And then go ahead and place. I'm going to push down 2 cc's. And the reason we put the PNP and then the sample is we need the invert emulsion to break up. So what we can do now is start moving this. I'm going to use a magnetic stirrer so I can go faster. Now we need this to be homogeneous, and I believe it's already pretty homogeneous. So I'm ready to add about 200 milliliters of deionized water. Stirrer is working fine. So the next step is to put some phenolphthalein. We are going to add, as a matter of fact, 15 drops. And we will have to neutralize this. So that's the reason we are using this color indicator. That's 15. Now a pink color will show. It's already showing very clearly. This is turning reddish, but I don't have any problem in seeing that this is pink. And we are going to neutralize it with a 0.1 normal solution of sulfuric acid. Now I'm ready for the sulfuric. The measurement of the alkalinity of the whole mat is going to be proportional to the number of cc's that we get to neutralize the alkalinity. The number of cc's of sulfuric acid, 0.1 normal. I'm going to continue doing this, and the pink color has to disappear and stay off for no less than a minute. So once I reach the final point, I'm going to make sure that the pink color stays away. Sometimes, in order for me to verify that, I might have to stop the rotation, the steering here. Now we got a pure brown. I'm going to make sure that it stays this way. That means we have neutralized this emulsion. Looks to me like this is pretty much pure brown with no trace of pink. I'm going to have to wait approximately a minute and see if I see any tones of the pink color coming back as a consequence of the protons being absorbed by some alkaline elements that are still in solution. Yeah, the pink color is gone, so I'm going to report alkalinity as 0.8. That would be the amount of acid I used divided by the 2. That's going to give me alkalinity of 0.4. This is the alkalinity of this invert emulsion. The next step, I'm going to lower the pH of the water phase, making sure that the pH is below 7 by adding 10 or 20 more drops of the same acid I've been using so far. So I'm going to go ahead and put, let's say, 20 more drops. I think that's going to be enough. So what we have to do now is to go ahead and place about 60 drops of potassium chromate indicator solution. That would be 50 and 60. So here we have a yellowish color. So now I'm going to proceed to titrate with silver nitrate, because this is an invert emulsion. I know that the amount of chlorides is going to be very high. So what I'm going to do is use the most concentrated of the silver nitrate solutions, the one that comes as 0.282 normal silver nitrate. That means that 1 cc of silver nitrate is going to be equivalent to 10,000 milligrams per liter of chlorides. So we are ready to titrate. We are going to do this with a 10 cc pipette. Remember, the color will have to go from yellow to pink. Now, this is going to be a very soft pink because it's going to be very diluted. It's not like when we were doing it in water, which was prevailing. In this particular case, we are doing it in an emulsion in which there is very little water. So the pink is not going to come very clear. It might take more than one pipette. Stop the stirring just to let the faces separate, but I don't see any trace of pink here. So I'm going to continue the titration process. Stirring very well. Oh, I can see now that there's a turning point. There's going to be a phase separation, water down, oils and alcohols up. This is the final point. Yes, this is clearly the final point. We are not looking for a very strong pink color, but just a certain tone of a pink or a trace of a pink, and this is it. And we got it with 9.4 cc's of silver nitrate, the one which is most concentrated, 0.282 normal. So briefly, the calculations would be 9.4 times 10,000, that comes to about 94,000, divided by 2, which is the size of the sample. We got 2 cc's. So we come to 47,000, and this is milligrams per liter of mud, of whole mud. That's practically the salinity of this invert emulsion we just checked. And this concludes the determination of chlorides.